DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, single stranded binding proteins, DNA, guide rays keeps the DNA from supercolon.
Initiation, let's make that cell divide. Gotta get that DNA to copy side to side. Proteins bind to the origin site, while the helicase unwinds for the highlight. Nucleosomes, what may these be? Structures formed by histones inside of me. DNA opens up, replications forms appear. They extend in both directions, just to be clear. DNA fragments are joined by the ligase. Elongations follows next into the cell place.
DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, the single strand and binding proteins, DNA, guide rays keep the DNA from supercolon. Now it's ready for initiation. Talking about that leading strand, the 3-5 prime direction. RNA primer comes and binds at the end of it. This begins the process of the DNA synthesis. DNA polymerase start coming along and adding bases. DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, the single strand and binding proteins, DNA, guide rays keeps the DNA from supercolon. Talking about that lagging strand.
The lagging strand, yeah, it got problems. If you saw a diagram, it's at the bottom, starting from the 5 prime to the 3, but the Okazaki fragments are complementary. RNA primase lays the primer down, so DNA polymerase 3 can add new base pairs from A to T and G to C. The fragments bind on and off sporadically. So when it started, the okie dokies were not binded. So to finish it up, we gotta link them up. The polymerase 1 comes down from the cytose, swiping the RNA primer with the DNA. There has to be a ligase present too to seal the deal, cause now we done with step 2.
DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, the single strand and binding proteins, DNA, guide rays keep the DNA from supercolon. Now we ready for termination. Let's go.
Termination is the last process of replication. It happens right before chromosome segregation. This occurs at many sites in our chromosomes. To prevent too much replication, who would have known? 2 replication forks meet at opposite ends. DNA replaces RNA primers, and then sugar phosphate backbones are sealed by an enzyme. An enzyme known as ligase. Keep that in mind.
Replication happens in cell division, necessary for your body. Grab the boys and start a party. DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, the single strand and binding proteins, DNA, guide rays keeps the DNA from supercolon. DNA replication happens in cell division, necessary for your body. Grab the boys and start a party. DNA replication, that DNA, then you unwind it with that helicase, then you hold it apart with those SSBPs, single strand and binding proteins, DNA, guide rays keep the DNA from supercolon. DNA, guide rays keep the DNA from supercolon. DNA replication happens in cell division, necessary for your body. Grab the boys and start a party.